Okay, this is lesson 4 in chapter 6. We are looking at a different format for an equation of line today. We're doing the slope point form of a linear function. So this equation is really useful if you have a slope and a point on the line. Actually, you know what, I'm going to use a different color. I'm going to use pink. Last lesson we did, just to review a little bit, we did the slope-intercept equation. I'm just going to move my screen over a little bit so you can see my writing there. And that one was really useful if you happen to have the y-intercept and the slope, but we don't always have the y-intercept. So if you look at this graph here that I have in the box, the y-intercept is kind of unclear. It's somewhere between 1 and 2, but it's not obvious what exactly it is without doing some better calculations. So sometimes we don't have the y-intercept, and in that case we want to use the slope point form for a linear function, and this is the formula for it. Okay, so y and m again are your y and x are your variables, so those are the numbers that we see on the two axes here when we have a graph, and all of the other numbers are constants. So the m again is the slope. Okay, I'm just going to erase this pink circle, and a point is given on the line. So the x1 represents the x coordinate of the point, and then the y1 would be the y coordinate of the point. So there's your point, and then m would be your slope. Okay, so let's look at this example again here. I have a line. I've counted out the slope already. It's -3/5. And a point on the line, I can see right here, the coordinates are 4, -1. So the x value is 4, the y value is -1. And so this is how the equation would look. It looks a little bit different from how you would normally see equations with just y equals. We do have the 1 here on the side with the y, but that's how the format of this equation looks. So it's y minus -1, so it turns into y plus 1. And then here's our m, and then it'd be x minus 4. Okay. So that's our example, and we're just going to practice using this format of equation today. And again, this is useful, especially when you don't have the y-intercept, like in this example here. Okay, so let's go ahead and practice graphing. So here it says, describe and graph the equations. So I'm just going to write the format here just underneath. So the format for the equation is this. Okay, so the m is the slope, and then the x1 and the y1 are coordinates of a point on the graph. So what we have to pay attention to is this negative sign. That's really important. So if we see the sign has been flipped, like here, that means our x coordinate must be negative actually. So it cancels with that other negative and makes it positive. So let's see what we have here. So we have our slope for our graph as 1/3, and the point on the line, the coordinates of the point are -4, because the negative must have canceled with this negative to make +4 there, so careful with that, and then 2 for the y coordinate. Okay, so let's go ahead and graph this, and you want to start with the point and then count out the slope. So we're going to start by graphing that point. -4, 2 is right here. I'm just going to label it. You don't need to label it, but just doing that for clarity. And then we're going to count out our slope. So we're going to count 1 up and 3 to the right. Rise over run. I'm going to put another point, and I'm just going to keep counting. 1 up, 3 to the right. 1 up, 3 to the right. And I just keep going until I run out of room. And I want to do a nice straight line through those points, and there's our graph. And you can erase any counting marks you made because they're not actually part of the graph. Okay, great. So that's how you graph a line from a slope point equation. All right, let's do this one. So let's write down our slope and our point. Okay, so the slope is going to be this number here, -1/2. And the point is going to be 2 for the x-coordinate and -1 for the y-coordinate. Reminder that there should be negative signs here. So because this sign is a positive, that means the y-coordinate actually would have been -1 to cancel with that negative sign. Okay, so there's my point. And we'll start with the point and then count out the slope. So the point is here at 2, -1. And my slope is -1/2. So 1 down, 2 over, 1 down, 2 over. I can count backwards 2. 1 up to the left, 1 up to the left. And I just make enough to use the entire space there. And then I draw a nice line through those points. Now you should use a ruler, but I can't use one on the screen. So I just do my best. Okay, and that's how you draw the line. Now I'm just going to label this point. This was my original point here, and this was my original point there. Okay, great. Let's go do another example here. Okay, this time we have an equation, or sorry, we have a graph and we're going to write the equation. So it says write an equation in slope point form, and it says for part B, convert the equation you wrote into slope intercept form. What is the y-intercept? Okay, so let's do part A. Now we have a choice here. We can choose which point we want to use. I'm just going to use this point here, 3, 1. I'll just keep everything positive. But you can also choose to do the other point. You'll get the same answer in the end. The equations are equivalent actually. So it doesn't matter if you choose this point or this point, you'll get an equivalent equation. And you'll get the same answer for part B. So we're going to use 3, 1 for our point. And our slope, we're going to have to count that out. So our slope will be, I'll count from this point to this point. I count 1, 2, 3 up and 1, 2, 3, 4 to the right. So it would be 3 over 4. Okay, so here's our equation. Y minus 1 equals 3 over 4, x minus 3. So the coordinates of the point go here and here, and then the slope goes there. So there's our equation. Now, this equation is in slope point form, but what if I wanted to convert it to y equals mx plus b? So that's what we're asked to do in part B, to y equals mx plus b. So what I want to do is just use some algebra rules to rearrange that equation and change it into y equals mx plus b format, and then we can tell what the y-intercept is. It's not obvious from the graph what the y-intercept is. It's somewhere between -1 and -2, but hard to tell exactly. So we're going to use this equation to do that. So let's start with our equation that we have there. Y minus 1 equals 3 over 4 x minus 3. Now, first thing I'm going to do is just get rid of those brackets, because in the slope-intercept format, there's no brackets. So I'm going to expand. I'm going to use orange for all my secondary color today. So we're going to expand the bracket. So I'd have 3 over 4x minus 9 over 4. Okay, now I'll just move this 1 to the other side, because in the y equals mx plus b format, I don't have any numbers on the left-hand side. So that cancels with 1 over here. So I'll have 3 over 4x minus, and then it'll be 5 over 4. Let me prove that to you. When I do -9 over 4 plus 1, that's the same as -9 over 4 plus 4 over 4. I can change it to have a common denominator, and then I can add the numerators together, which would be -5 over 4. So here's my final answer. This is the equation in slope-intercept form. And notice the slope didn't change, but here I can read off the y-intercept, -5 over 4. So the y-intercept is -5 over 4. That's the other part of the answer. Okay, great. So you can convert back and forth between different equation types in this way. Okay, last one is a word problem. Slope point form is really great when you're given a word problem where you are not given sort of a starting point. Okay, so this is an example of that. Carl is on a bike ride and is tracking his distance from home. At 5 minutes into the bike ride, he is 18 kilometers from home. So I'm just going to highlight this. At 5 minutes into his bike ride, he's 18 kilometers from home. And at 20 minutes into his bike ride, he's 12 kilometers from home. So essentially, they're just giving us 2 points on the line there. So here for part A, it says write a linear equation. So we're going to start with, we are given 2 points. So often word problems in where you're asked to do slope point form, they give you 2 points to start with. So we're told that 5 minutes into his bike ride, he's 18 kilometers from home. This would be like the X, this would be like the Y. And then the other one is 20 minutes into his bike ride, we're 12 kilometers from home. X, Y, okay? So let's just call this one X1, Y1, X2, Y2. Since this is the first point, that's the second point. Okay, if I want to make a slope point equation, I got to figure out the slope. Well, I can figure out the slope because I have an equation for that, y2 minus y1 over x2 minus x1. So I just need to figure out the change in y values divided by the change in x values. So those would be given to me here. So it would be 12 minus 18 over 20 minus 5. So 12 minus 18 is negative 6, and 20 minus 5 is 15. And I can divide those both by 3, and I get negative 2 over 5. Or you can write it as a decimal, it doesn't matter. I'll just leave it as a fraction. Okay, so there's my slope, and I can use either one of these points. I'll just choose this one, and now I'm going to write my equation. It doesn't tell us what variables to use here, so I'll just stick with x and y, but you could also do d and t for distance and time. It's up to you, but we would write it in this format: y minus y1 equals m x minus x1, and we have our point. We could use either point here. The equations are equivalent, but I'm just using the first one. So here we'd have y minus 18 equals negative 2 over 5. And you could do the decimal one as well. It doesn't matter. X minus 5. So there's my equation. Okay. And again, you could use different variables to better describe the equation if you wanted to. So here, because it's distance and time, you could use d and t. Those are equivalent equations. It doesn't matter what letters you use. Okay, now in part B, it says use your equation to determine when Carl arrives home. So part B, when does Carl arrive home? Well, so we want to find the time. So the distance, or the y value, when he arrives home would be 0. The distance from home would be 0 when he arrives home. So I'm going to plug that into the y position and solve for x, solve for the time. So 0 minus 18 equals negative 2 over 5, x minus 5. And I'm going to expand. Actually, yeah, there's a couple of options here. I'm going to just evaluate this left-hand side. Okay, and then I'm going to start by dividing by negative 2 over 5. Dividing by a fraction is the same as multiplying by its reciprocal. So we'll do that on this side over here. And then I'm going to just bring my work up here. So 5 over 2 times 18 is 45. And it's negative because it's negative there. And that canceled this out here. So I'm just left with x minus 5 now. And then I'm going to add 5 to both sides. But why is my... Oh, it won't be negative. I was thinking, why is my answer negative? It's not negative because we have negative 18 times negative 5 over 2. So those negatives cancel. There we go. Okay, good. So 50 equals x. So it takes 50 minutes. There we go. Another option for solving this would have been expanding this bracket, but then you increase your steps. So I chose not to do that. I chose to divide first. Okay, and that's the end of the lesson.